Why does fire exist? It sounds like a simple question, almost childish. You've seen fire your entire life. Candles, matches, stoves, campfires. You strike a match, something burns, flames appear. End of story. Most people never stop to ask why. Fire is hot. Fire is bright. Fire destroys things. That feels like enough. But it isn't. Because the moment you seriously ask what fire is, not poetically, not metaphorically, but physically, you fall through the surface of reality. Fire is not a thing you can hold. It's not a substance. It's not an object. Fire is a process. And understanding that process quietly connects atoms, sunlight, trees, oxygen, your own body, and the rules that decide when energy is allowed to move and when it isn't. To see it, start with something completely ordinary. A piece of wood, dead, still, doing nothing. Now add air, oxygen everywhere, floating freely, constantly colliding with the surface of the wood. The wood has been sitting there for years. The oxygen has been there the whole time. Nothing happens. That should already feel strange, because the wood is full of carbon, and oxygen chemically wants to be next to carbon. When carbon and oxygen bond, energy is released. A lot of energy. That bonded state is more stable, lower energy, more comfortable. So why isn't the wood already on fire? Why can a piece of wood sit in open air for decades, sometimes centuries, without burning? The atoms are not waiting patiently. They're colliding constantly. Millions of collisions every second. Oxygen atoms slam into carbon atoms over and over again. And then, nothing. They hit, they bounce, they separate, again and again. Because wanting to react isn't enough. There's a barrier. To bond, the atoms have to get extremely close. Closer than they naturally can at room temperature. Getting that close requires extra energy, just enough to climb over an invisible hill. As long as they don't make it over that hill, nothing happens. The system sits there, full of stored energy, frozen in place. This state has a name. It's called metastable. The system wants to change. It just can't get started. And this is the first deep truth hiding inside fire. Before any flame appears, before any heat or light, the universe is already sitting on energy that wants to be released. Energy locked behind a barrier. All it's waiting for is a push. And once that push happens, the calm you're looking at disappears almost instantly. That push doesn't need to be dramatic. It doesn't require a huge explosion or some magical event. It just takes a small pocket of atoms moving slightly faster than usual. Heat. When you strike a match, you're not creating fire. You're not adding anything special to the universe. You're simply giving a tiny number of atoms enough energy to climb over that barrier. Most atoms still fail. They collide. They bounce away. Nothing happens. But a few succeed. A few oxygen atoms hit carbon atoms with just enough speed. They get close enough. And when they do, they snap together. That snap releases energy. Not metaphorical energy. Real, physical energy. That energy doesn't disappear. It goes straight into motion. The nearby atoms start jiggling faster, vibrating harder, moving more violently. And now something crucial happens. Those faster atoms collide with other atoms. They pass along that energy. They make those atoms move faster. Some of them now have enough energy to climb over the barrier too. They snap together. They release more energy, which makes even more atoms move faster. And suddenly the situation is no longer calm. This is not a gradual process. It's not slow. It's not controlled. It's a chain reaction. One reaction triggers two. Two trigger four. Four trigger eight. In a fraction of a second, the number of reacting atoms doubles again and again. Billions of atoms are snapping together almost simultaneously. That runaway process is what you see as fire. Fire doesn't grow because it wants to spread. It spreads because heat creates the conditions for more heat to be released. The reaction feeds itself. The energy released by one bond breaking and reforming provides the energy needed for the next bonds to do the same. It's a feedback loop. Once it starts, it accelerates. This is why fire seems to appear suddenly, not slowly, not gently. One moment nothing is happening. The next moment, the entire system is in motion. The heat you feel near a flame is not some invisible fluid flowing into your skin. Heat is motion. It's atoms moving faster. Put your hand near a fire, and the atoms in the air collide with the atoms in your skin, transferring that motion. Your nerves interpret that motion as heat. Fire is not a substance. It's not a material. It's not even really a thing. It's a catastrophic transition, a system trapped behind an energy barrier suddenly finding a way out. And once that escape begins, the universe does what it always does. It rushes downhill. When the universe rushes downhill, it never does it quietly. All that motion, billions of atoms snapping together, vibrating, colliding, has consequences you can see. Light. The flame is not the fuel. The flame is not the wood. The flame is energy making itself visible. When carbon and oxygen snap together, the energy released doesn't just go into random motion. Some of it excites atoms and molecules, especially electrons. Electrons are kicked into higher energy states, unstable positions they can't hold for long. They fall back down. And when they do, they release that excess energy as light. That glow you see dancing above a fire is not the wood burning. It's atoms shedding energy. Different atoms release light differently. That's why flames have color. Sodium gives yellow, copper gives green, strontium gives red. Fireworks exploit this. They're just carefully controlled chemistry designed to make electrons jump and fall in very specific ways. So the flame is a signature. A visible trace of energy being released as bonds form. The smoke rising above the fire is something else entirely. Tiny particles that didn't fully react, heated until they're less dense than the surrounding air and carried upward. The darker the smoke, the more incomplete the reaction. And the ash left behind? That's almost nothing. Just minerals, calcium, potassium, trace elements, the tiny fraction of the wood that didn't come from the air. This is another moment where intuition fails. We think wood disappears when it burns. It doesn't. Most of it becomes invisible gas, carbon dioxide, water vapor. It spreads out into the atmosphere, drifting away, too diffuse to see. The mass didn't vanish. It changed form. Fire doesn't destroy matter. It rearranges it. And this is where fire stops being a curiosity and starts becoming a window. Because once you understand that fire is atoms seeking a lower energy arrangement, driven by a runaway release of stored energy, you start to notice something unsettling. The wood didn't create that energy. The oxygen didn't either. The energy was already there, locked into the structure of the wood itself. Every bond holding those carbon atoms, apart from oxygen, was holding energy in place, like a compressed spring. Fire isn't creating energy, it's letting it go. Which raises a deeper question. If the energy in the fire was stored inside the wood, how did it get there in the first place? Because a dead piece of wood sitting on the ground doesn't look like something that should be full of trapped energy. It looks inert, lifeless, but it isn't. It's a battery, and understanding how that battery was charged pulls fire out of the fireplace and straight into the sky. That battery was charged slowly, painfully slowly. A piece of wood doesn't store energy by accident. It's the final result of years of quiet work, happening somewhere else. Look at a tree. It feels obvious to say the trees come from the ground. You plant a seed in soil. The tree grows upward. It gets bigger, heavier, solid, so it must be made out of the ground. But that's almost entirely wrong. If you take a pot of soil, weigh it, plant a seed, and let a tree grow for years, then dig the tree out and weigh the soil again, the soil weighs almost the same as it did before. A little mineral loss. Almost nothing. Yet the tree weighs hundreds of kilograms more than it did as a seed. So where did all that mass come from? Not from the ground, it came from the air. Trees are built mostly out of carbon, and that carbon comes from carbon dioxide in the atmosphere. Every leaf is quietly pulling carbon atoms out of the air, one molecule at a time. This is the part that feels backwards. Carbon dioxide is carbon already bonded to oxygen. And as you've seen, carbon and oxygen prefer to stay together. Pulling them apart requires energy. Trees don't do this because they're clever. They do it because the sun is doing work. Sunlight hits the leaves, and that energy is used to rip oxygen away from carbon. The oxygen is thrown back into the atmosphere as waste. The carbon is kept and stitched together into sugars, cellulose, wood. Photosynthesis is not growth, it's theft. Energy is being stolen from sunlight and used to force atoms into an unnatural, unstable arrangement. Carbon and oxygen are being held apart against their preference. That separation is stored energy. Every tree is a structure built out of tension. Carbon wants to fall back into oxygen. The tree keeps them apart for years, decades, sometimes centuries. And the oxygen that fills the air around you? That's waste. Plants don't want it. They throw it away. The early Earth had almost no free oxygen at all. Oxygen accumulated only because plants kept dumping it into the atmosphere for millions of years. Fire is only possible because life made the air flammable. So now look again at that piece of wood. It's not dead matter. It's sunlight, reorganized. It's years of photons captured one by one, stored as chemical bonds, frozen in place. When you burn wood, you're not creating energy. You're releasing the sun. The light flickering in the flame is energy that once fell on leaves, maybe years ago, maybe decades ago. Stored patiently, waiting. Fire is just that stored sunlight escaping all at once. And once you see that, the fireplace stops feeling small. Because the same process that lights a match is tied directly to the star that keeps the planet alive. That connection doesn't stop at trees. It moves straight into you, because the oxygen filling the air right now, the same oxygen that feeds a flame, is also feeding your body. Every breath you take is part of the same story. Inside your cells, carbon is reacting with oxygen, slowly, carefully, under control. This is not a metaphor. What your body is doing is chemically identical to fire. The only difference is speed and precision. You eat food made of carbon-based molecules, sugars, fats, proteins, all built originally by plants using sunlight. Inside your cells, oxygen combines with that carbon, step by step, releasing energy. That energy doesn't explode outward as flame. It's captured, stored, used to move muscles, maintain temperature, power thought. This process is called respiration, but chemically, it's combustion. You are burning fuel. The carbon in your food is snapping back together with oxygen, releasing energy, exactly like a fire does. The carbon dioxide you exhale is the same carbon dioxide a flame produces. Same reaction, same outcome. You are, in a very real sense, a slow fire. And the oxygen that makes this possible? That oxygen exists because plants spent billions of years tearing carbon dioxide apart and dumping the oxygen into the air as waste. For early life, oxygen was poison. Entire ecosystems collapsed when oxygen levels rose. But some organisms learned to exploit it. They learned how to use oxygen to extract enormous amounts of energy from carbon without destroying themselves. That trick reshaped the planet. Fire, breathing, metabolism. They're all expressions of the same chemical tension. Carbon wants to be with oxygen. The universe rewards that reunion with energy. The difference is control. Fire releases energy as fast as possible. Life releases energy just fast enough. Your cells use enzymes, molecular tools, to lower the barrier that atoms have to cross. They provide a gentler hill, allowing reactions to happen at body temperature without runaway catastrophe. That's why you don't burst into flames. Your body is full of metastable systems, fuel and oxygen sitting side by side, wanting to react, held in check by structure and regulation. The moment that regulation fails, damage spreads quickly. This is why oxygen is both essential and dangerous. It powers life. It also slowly destroys it. Oxidation is fire stretched out over time. Rust is slow burning. Aging is slow burning. Life exists in a narrow window between too little energy and too much. And fire marks the edge of that window. It's what happens when the same chemistry that keeps you alive is allowed to run without limits. Once you see this, fire stops being external. It's no longer just something you light. It's something you participate in. Every second you're alive, the same fundamental reaction is happening inside you. Carbon returning to oxygen, energy flowing downhill. The flame just does it out loud. Once you see fire this way, it stops being a special event. It becomes a pattern. Everywhere you look, the universe is full of systems sitting behind barriers, packed with energy, waiting. Not frozen forever, just waiting for the right conditions. Wood and oxygen, fuel and air, food and oxygen in your cells. They're all metastable, balanced on a hill, not at the lowest point, but stuck there until something pushes them. The universe is full of these states because they allow structure to exist. If everything immediately fell into its lowest energy configuration, nothing interesting would ever happen. No trees, no life, no thought, no history. Energy barriers are what make time meaningful. They allow the past to exist separately from the future. They slow things down. They let complex arrangements persist long enough to matter. Fire is what happens when one of those barriers fails catastrophically, but the same idea shows up in quieter places. A star shines because hydrogen sits behind an enormous barrier. When gravity finally pushes it over, fusion begins and energy pours out for billions of years. Your body works because enzymes carefully lower barriers just enough to release energy without destroying structure. Even ideas behave this way. Long periods of stability, followed by sudden change when a threshold is crossed. Fire isn't an exception, it's a demonstration. And once you understand that, the original question changes. Why does fire exist? Because the universe is built to store energy, not just release it. Because sunlight can be captured, delayed, and returned. Because matter can be held away from equilibrium long enough to build complexity. Fire is what equilibrium looks like trying to reassert itself. When you watch a flame, you're watching the universe erase a structure that took years to build. Carbon falling back into oxygen, stored sunlight escaping, order dissolving into motion. Nothing mystical is happening, and yet nothing trivial is happening either. Fire is the universe reminding you that everything solid, everything stable, everything alive exists only because it hasn't fallen yet. Because barriers are still holding, and one day, inevitably, they won't. That's not something to fear. It's something to notice. Because the same rules that make fire possible are the rules that let trees grow, stars shine, and you sit here long enough to ask the question in the first place. Fire doesn't destroy that story. It completes it.